Welcome to another episode of Cuda Education. Okay, guys, so we are continuing our investigation of the ray tracing glTF script algorithm. And, what I wanted to spend a little bit of time on is the placement of textures and also a little bit of playing around with the index of the texture that we use in terms of like the the color and all of that stuff, right? So as you guys know, we have our glTF model, right? And it is pretty cool, I must admit, right? It's a helmet. Okay, so what I want to focus on is basically the placement of the textures, right? So specifically even looking at where the straps are and how they're placed, all of that stuff, right? You see we have our goggles here and everything. We have our hose, all of that stuff, right? Okay, so I want to focus on this UV parameter. So there's a thing called UV coordinates, and in a nutshell, what it is transforming a 2D object or image and graphing it to a 3D object or image. So in the simplest terms that I could describe this, it's like taking a map of the globe, right? A 2D map of the globe, like say a map on a sheet of paper, right? A two-dimensional map of the world on a sheet of paper, taking up the sheet and wrapping the sheet around a globe. So you have a spinning globe, and then you're gonna take that sheet and you're gonna paste or tape or glue the map of the globe onto the globe itself, right? So the two-dimensional sheet, that's the map of the world, right? The map of the world, and you're gonna paste it onto this globe. So now you have a global representation of the world, right? Of Mother Earth, right? That's what this UV coordinate is, okay? So notice that we're doing all this stuff and we're assigning it to the variable color, okay? And if we want to, we also add occlusion to color and stuff, and then we assign hit value to color. So remember, hit value is basically for each pixel in our scene, where there's a ray intersection, what is the color, what is the representation, what is the value of that pixel. And that's what, over thousands and millions of pixels, that's what creates our image, right? So what we want to do is tinker with this UV value, right? This UV value for it's for the texture calculation and for what eventually resolves to the color, right? I just want to focus on this for now, right? So I just do a little thing right here, vec2uv equals try.uv, and try is it's it's vector acrobatics and variables and stuff like that, arrays and stuff, unpack triangle, which I'll get to at some point. But I just want to focus on this idea of UV coordinates as it relates to textures, right? So I basically assign this try.uv to this UV variable, and then now I'm going to start to manipulate how the map of the world, the map of Earth, how it translates to the 3D space, or how it translates to when we wrap that sheet now around the globe. So guys, you know, of course, that I have to compile again. So now I'm tinkering with the value of this UV variable, right? That as it relates to texture, as it relates to color, which eventually, you know, affects hit value, right? So we're just basically trying to play around with the UV variable so that we could get, you know, we could understand, you know, how texture works and how it you know, how it relates to our glTF object, etc., etc. Now remember, these files, the texture files, are 2D objects, but now you can see things get sort of screwy, right? I'm not even going to attempt to explain it, but you could just see that things have moved around. The textures have moved around, right? You know, the textures are sort of misplaced in different areas, right? Things aren't exactly, you could see even on the hose right here on the tube that we have different things going on, right? So we're playing around with where the textures are laid out onto the object itself. Okay. So that's just one representation. We could play around with it some more. So we do another mathematical operation on the UV variable. And then we're going to see again how it affects how we wrap that two-dimensional map onto the globe, right? How we skew it, how we transform it, how we change it up, move it around, things of that. So this texture conversation is obviously very important. It's an important thing to understand for photorealism, for computer graphics, for all that stuff. I just wanted to focus sort of on the UV portion of this. We will also play around with the color, the color aspect of it in a second. All right, so I have now compiled already. So now let us look at what we get. So we get further chaos and confusion, right? Now things are all over the place, right? I'm not going to sit here and try and explain it, but you could basically see where you know, things are not being mapped properly onto the image, right? So that is when we play around with this, how we map a two-dimensional thing onto a three-dimensional object, right? So it's actually pretty important for you guys that are into geometry and all that stuff, algebra, geometry. This is your lane, right? So we're gonna do it one more time with this transformation, and we're gonna see exactly what is going on. And remember, guys, we're trying to affect this color variable, which it eventually affects the hit value. And remember, hit value is it was generated from, it started from the regen, right? So this variable originated from regen, and it was received into the hit, the closest hit shader via ray payload in ext, right? You guys should remember this from previous lessons, from previous videos. Ray payload in ext, right? So this guy right here, right? So we basically receive this variable, and then we make modifications based on all that's happening here. So let's look at our result now. So we have again further modified our position, and you could sort of see, like, this is where the straps are now, right? In terms of its texture, right? And you could see that, like, the texture has changed. you know, everything is sort of messed up again, right? Because it's not being laid out properly onto the image. Okay, so that's your lesson on UV coordinates, right? And you know, surely I'd love you guys to dive into it some more, but that's that. So we're done messing with UV coordinates, but as you can see, um, you know, we're again affecting this color variable, and we have to figure out where are we applying this how are we applying our 2D texture object onto the 3D space or world, right? So let us let us go back. All right, so let's just go back to normal just to make sure that we're back on the same page. Okay, guys, so for what it's worth, these are sort of the 2D texture files, if you will, of the image. So notice that you could kind of see some relation to, you know, what's actually on our helmet, right? So these are the 2D texture files. You know, that helps make our map photorealistic looking, right? So there's a lot of opportunity for you guys in the creative arts, for you guys to really figure out and understand what's going on. Okay, so these are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so notice that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, so we have 15 sort of quote unquote texture files. So let's just make sure we're back to baseline. So we're back to everything being where it's supposed to be, and our image looks nice and clean and cool. Everything is where it needs to be, right? This is a glTF file, okay? So now, what we want to do now as the last thing, I don't want to get too much into the technicalities, but as the last thing, I'm going to force for every pixel, right? So for every pixel that's for every pixel in our scene, I'm going to force the color to be a specific value. All right. So I'm going to force the color now, no matter what position or place or pixel that we're contemplating in our scene, onto our object, right? This is assuming a hit, of course, because we are in the hit shader. So, you know, we're only dealing with places where a pixel has hit something or array has hit something, right? Pixels where array has hit something. I'm now going to force a specific color, a uniform color on all pixels that represent a hit, right? So I'm going to force 0, right? So we get this. Now, yeah, I can't really tell you know, why some places it's this, but I'm gonna assume 0 is this, right? So we're just gonna keep going. We're gonna keep going. Now, remember guys, I counted 14 images, right? So if I counted 14 images and I start counting from 0, what's the highest number that this should be able to go to? If I counted 15 images and I start counting from 0, what's the highest number that this can go to? If you guess the number 14, then you are correct, right? So this number should be able to go all the way up to 14, right? And then if we go further, we'll see what happens, right? So see, so now I get something more along the lines of what I expect, where everything is just sort of one. And remember, we saw our texture file, so we know exactly what's going on here, right? So you're just graphing one color onto the whole thing, right? So we could do 2. Again, I have to recompile, of course, guys. So you know, we're gonna see as we progress along that we're gonna get to see different because remember, this is like texture index base color, right? So we're gonna get to see all right, started audio. Right, so we get to see that it's a different thing for each one of them, right? And you know, if we go to all the way to 14, we will get something again. So remember, 0 to 14 counts to 15 textures, right? 0 to 14 is 15 textures, right? So when you start counting, remember, you don't start counting from 1, you start counting from 0, okay? So then if we go past the number of textures, what do you expect to happen? If we give a number that is past the number of textures that we have, what do we expect to happen, right? All right, so let's go to 14, right? All right, 14 is still this again. I'm not gonna, let me do 12. Just to see if we get something different again. But you know, basically we are now, you know, applying a color, a color maybe map, if you will. But again, it's this two-dimensional thing, and we're wrapping it around our image in 3D space. So that's what this UV thing is, and that's what this base color index thing is, right? So I think I could go now. All right, so we get something different again, right? So you guys kind of get the picture now. So we have, you know, but this is sort of taking one texture and just applying it to every pixel in our scene. So now what if I do 15? What's going to happen when I go past the number of textures that I have available? Like, so these textures are sort of an array. They're an array in they are an array in a file. Where is it? Yeah, it's an array in a file, right? And I guess the glTF file from 0 to 14. So if I go past that number, what do we expect to happen? We expect to have nothing. So we still have our goggles, right? But you could see that there's nothing because we have now moved past all the textures available, so nothing is applied onto them, right? So there you have it, guys. Right? So that's what we call texture index base color. Okay? So we understand texture index base color and we understand the UV coordinates, right? Let's go back to base, make sure that we're back to where we left off. Guys, you always have to, you know, good housekeeping in programming. You know, make sure you leave things properly, because if you leave and then you come back and you're not at base, you're gonna maybe forget what changes you made, and you don't remember how to get it back to what was the normal thing, right? So we sort of talked about UV coordinates, and then we talked about this texture index base color, and we saw the texture files, the 2D texture files that are being applied. These are some, memory address operation stuff, which, it's a whole nother topic that we will have to address at another time. Let's make sure we're back to normal. We are back to normal. All right. So there's a lot that goes into this stuff. It's not just, it's not simple stuff. For you guys that are artistically inclined, graphic designers, illustrators, people that are into drawing, visual arts, painters, designers, all of that stuff, this is your wheelhouse. I personally am not artistically inclined. I just show you the way. That's what Cuda education is for. We show people the way and enable people to reach their fullest potential. So as you can see, guys, this glTF stuff is pretty involved, right? It's a lot of moving parts. But thankfully, the author, Sascha Willems, has done a great job in making this available to the world. So you could start from here and start making changes and modifying things to your heart's content. And that's textures, guys. So that's, we have our index base color and we have our UV coordinates. We'll get into the other stuff here, but again, we're affecting this color variable. We're pushing everything into this color variable, which eventually lands into the hit value. And hit value is basically what, what gets returned to our eyes, right? So we we retrieve back hit value, and that's what we end up seeing. All right, so this is Cuda education, guys. Tutorial number 1 to install the Vulkan API. Tutorial number 13 to install all of these examples, assuming you have a ray tracing capable GPU and also a Vulkan capable GPU. I assume that you have a Windows machine with a GPU that's Vulkan capable and also ray tracing capable. If your GPU is only Vulkan capable but not ray tracing capable, you'll be able to run these examples but not the ray tracing examples, right? For NVIDIA, it's the RTX cards and greater and later. For all the other vendors, AMD, Intel, it's different. I don't know the models for those, right? But definitely, guys, if you are artistically inclined, if you're interested in computer graphics, if you are you want to learn something on your work commute, this is the place to hang out. So like, subscribe, ring the bell, all that good stuff. You guys are better at YouTube, really good at YouTube, so you know the deal. Support the channel, tell your friends. Time is the most valuable asset, so just spend your time investing and learning in this stuff. It's the future, especially for you creative people. Don't worry if you're not you have no experience with programming. All of my content and everything I do assumes that no programming knowledge. So start from scratch, keep at it, and every day you learn something new, and eventually you will be an expert, right? So yeah, guys, this is Cuda Education. Thank you for watching. Have a great day.